right, guys. Worksheet 6.2. What questions do we have? That's very unhelpful. Not all of them. Ben.
So for rounding,
yes.
some of the numbers I didn't get exactly right, but I was off by 0.01.
Yeah. So if you're off a tiny bit because your molar mass you rounded it slightly differently, that's perfectly fine.
Yeah, I was gonna say for number 9, I got a different molar mass for aspartame, and it completely threw off almost all of them.
What did you get for the molar mass of aspartame for number 9?
I got 284 point.
Well, that is an error on your part because that's wrong. So it's not a rounding issue. So just be careful because for guys, I'm on page 8, number 9. Okay, for 9A, for the molar mass, you have 14 carbons. 14 carbons, so 14 times 12.01. You have 18 hydrogen, so you multiply that by 1.01. 2 times nitrogen, which is 14, right? 14.01, I believe, and then oxygen is 16. Okay, so yeah, if you got 294.32 or 33, that's a rounding issue. That I'm not concerned about that. But if you got 284,
so now I get it right.
Yeah.
If
it's 100, off by the hundredths,
yeah, I got it.
Then that's fine. But if you're off by he was off by 10 full grams per mole, which is an issue.
I'm blind.
John.
Everybody makes mistakes.
For the molar mass, 3 decimal places is totally fine. Hey guys, other questions? So converting grams to moles, moles to grams, moles to formula units, or molecules or atoms, or from those particles back to moles, or even doing a 3-stepper you guys are comfortable with. Okay.
Can we do a 3-step on the board?
I'm only doing a 4-step problem on the board.
Whoa!
Okay, let's look at 9D.
Can we do it?
9D. 9 as the number, D as in donkey. All right.
D as in Elliot.
All right. So guys, if you look, I'm on page 8 for 9, D as in donkey. I have 5.0 milligrams of aspartame. And the question is asking you to go from milligrams into molecules. Okay, so someone had asked me at the beginning of class, am I going to give you your wheel, the wheel on that table? I'm not going to give that to you. Okay, so you need to be able to do this on your own. Here's the reason why this is a 4-step and not a 3-step problem. I give you milligrams. What is the first thing you have to convert into? Grams. So you're going to go from milligrams into grams. So what unit should I put on bottom? Milligrams, and put grams on top. Okay? Now I'm in grams. I want to eventually get into molecules. I can't do that directly. I first have to get into moles. So I'm going to get out of grams by putting grams on bottom, and I'm going to put moles on top. I'm going to keep going. Okay, I'm not going to put in values yet. I want to make sure I know what I'm doing. I'm now in moles. I want to get into molecules, so I'm going to put what on bottom? Moles, and what up top?
Mole.
Okay. Are we okay with those 3 steps?
Yes, ma'am.
Okay. So it's technically a 3-step problem, not really a 4-step. But all right. What is the relationship between grams and milligrams? Well, 1 milligram is how many grams? 10 to the negative third. Okay. Here, whenever you see grams to moles or moles to grams, I need to be using my molar mass. So number 9A asks you to actually calculate the molar mass, and I got 294.31. Remember, the molar mass is 294.31. The units are grams per mole. So where should I put this molar mass? On the top or the bottom? On the bottom. So it's going to be 294.31 grams for every 1 mole. Okay. And the last step if I'm going from molecules to moles or atoms to moles or formula units to moles, I need to use whose number? Avogadro's number. So 6.02 times 10 to the 23rd molecules in 1 mole. Are we okay?
Yes.
That's a lot of work.
He wasn't You owe her no. You owe her that.
You can't say it. Why not?
Go, ready, go.
It gets old very
I
quickly.
saw the class lecture.
Yeah, you watched it, and I said it in there, right?
Yeah, in Spanish, she was like, you can only say that word.
I was trying to pull my long guacamole.
Yep.
Oh my god.
My son thanks you in advance.
Oh wait, no, wait. So now I have to give you 2 of them.
Yeah,
Yeah.
2 of them, yes.
But
All right.
Don't say
So-
it. Don't say it.
2 of what?
Okay.
No, I was like.
Stop being mean. Okay,
That's all
so
we're good at.
I'm going to take 5.0. We're moving on. I'm going to take 5.0. Am I going to multiply or divide by 10 to the negative 3rd? Multiply. Multiply or divide by 294.31. Divide, and then I'm going to multiply by Avogadro's number. Okay. My final answer, because I have 5.0 milligrams, my final answer is going to have how many sig figs? 2. So my final answer that I got was 1.0 times 10 to the 19th molecules. Woo! And that was that. Right? Would I ask you a question like that on a quiz or a test?
Probably.
Absolutely.
Yeah.
Very likely.
I wonder what our quiz is going to look like today.
Indubitably. Are there any other questions from worksheet 6.2 before I give you your quiz? John? Yes.
An example, like
Probably not, because if you get A wrong, then I have to go through and check all of your answers. No.
Oh, that's
wrong.
If I gave you a test question like number 9, if you got A wrong, I would dock you for that. But then from then on, I would have to check all of the rest of your work, because if you use the wrong answer but did the rest of the work correctly, I give you full credit. Okay? Are we good?
Yes, ma'am.
Everything off your desk except for your periodic table, your pencil, and a calculator, please.
This time it's not for emotional support.
Indeed, yeah.
Uh-oh, spaghettos. Things are about to get a little bit wild down west.
not wet.
I don't know how.
For note 6.3, we looked at percent composition, and there are 2 different ways to calculate percent composition. The first way is if I actually give you the masses. So I am on page. What page am I on? I am on page 10. Okay? So if I give you the masses and ask for the percent composition, this is something that I'm hoping you're able to do already. So in the example that I gave you, I told you that if I weigh, let's say for example, 120 pounds, and 50 pounds of my weight is water, what percent of water am I? You would take the mass of what you're interested in, so the 50, technically that's weight, but whatever, and you would divide it by the total, so 50 divided by 120, and you would multiply by 100, and that would give you your percent composition. Okay, so let's look at number 1 and number 2 and make sure that we understand that really. So it says an 8.20 gram piece of magnesium combines completely with a 5.40 gram sample of oxygen. What is the percent composition of magnesium? What is the percent composition of oxygen? So I know I have 8.20 grams of magnesium, and I have 5.40 grams of oxygen. Okay. So to determine the percent that is due to just magnesium, what do I need to do? Divide what by what?
It's about the magnesium by the whole thing.
Okay, so I need to divide the mass of magnesium, which in this case is 8.20 grams. Hold on. Divided by the total mass of my sample. Well, I know I have 8.20 grams of magnesium, 5.40 grams of oxygen. So if I add these together, that gives me my total mass. So that would be 13.60. And then multiply the entire thing by 100. Okay? So I think it told you in the it didn't really tell you how to round it. I'm not going to be super picky for these. For this, 3 sig figs would be great because it's 8.20. So I got 60.3% for my percent composition of magnesium. So there are 2 different ways to do this. To determine the percent that's oxygen, I could do this exact same thing, but instead of 8.20, plug in the 5.40, divide by the total mass. Or I could recognize the fact that the percent that this plus this has to equal what? 100%. So what does this percent have to be?
It should be 39.7.
It has to be 39.7. Okay? So I think the hardest thing with number 1 and number 2 was just recognizing what each value represented. In number 2, it says a laboratory procedure. Laboratory procedures show that 50 grams of ammonia yields 41 grams of nitrogen and 9 grams of hydrogen. What is the percent composition of nitrogen and hydrogen? Okay, so here I've got 41 grams of nitrogen. Yep.
So ammonia is NH4, right?
Ammonium is NH4 plus, ammonia is NH3.
What's the difference? Like, no, I know like the formula. I mean,
This
like,
does not exist by itself. It's always with an anion, so like ammonium chloride, ammonium nitrate. NH3 exists by itself. This is a base. This is an acid.
Wait, you said that ammonia was a base.
Ammonia is a base. Ammonium is an acid. They're both weak acids and bases, but yeah. So you can clean with this. And then I have 9.0 grams of hydrogen. Okay. So to determine the percent that's due to nitrogen and the percent that's due to hydrogen, I need to take the mass of nitrogen and divide by the total mass, which is 50, because the total mass of ammonia is 50. Same thing here. So the percents that you get once you multiply by 100, you get 82.0% for nitrogen and 18% for hydrogen, because it needs to add up to 100%. This is just like, hey, what did you get on the math test? Well, I got 59 correct out of a total of, don't be negative, let's say like 61, right? So when I say what percent did you get, I'm saying what percent correct did you get? We could be technical and say, oh, what percent did I get wrong? And you would have put 2 out of 61. So what goes on top is what you're interested in, the percent that we're interested in, right? So whether it's the ones we got wrong, the ones we got correct, the mass of whatever we're interested in, and then you divide by the total.
Let's say that's my parents. Let's say I got a 2 out of 61. Let them freak out and then I'll say, well,
Just
wrong.
kidding. I only joke.
Have fun with that one. I'm not gonna encourage that, but okay. All right. So that's a little bit more like every day. You guys should have experienced that and done that before, especially since you guys get grades. Here's where the chemistry gets a little bit more heavy duty.
Molar masses.
If instead of giving you the mass, I just give you the formula, you're gonna have to determine the percent composition. Okay? So if you look at number 1, it says find the percent composition of carbon in ethane. So it's C2H6. Okay? So what I'm going to put up top is just the mass of carbon. Well, carbon has a molar mass of 12.01. However, how many carbons do I have? 2. So I'm going to do 2 times the 12.01. Okay? And I'm going to divide that by the total molar mass. So 2 times 12.01 plus 6 times 1.01, and what did you guys get? 20.
30.
Oh, wait, no.
I got 30.
Yeah, I got 30.07.
30 point what?
02.
Okay. Okay, so remember, this is slightly different from what we were just working on when I give you mass, but it's not that different. I'm saying take what you're interested in, put it on top, so carbon on top, and on the bottom put the total molar mass. Multiply this by 100 and you'll get your answer. So what did you guys get for your percent?
I got 80.
79.36.
I got
79.
I guess it might slightly change. I got 79.85.
I got 80.
Okay, that's
Okay, I think I know why. I think we.
Because all of us use different molar masses.
Yeah, that's why.
Okay.
Can we like stick to the class so that we know like?
You can. I won't ever take off. If you got 80.01 or I'm fine with that. I've got stuff memorized and I'm not going to go back to the periodic table. I'm sorry.
Okay.
So mine might be a tiny bit off of yours, but
So long as like we don't get dogged. for it,
you're
that's
not going to
fine.
get docked. Now, if you put 90.01, I will dock you because that's the wrong answer.
Okay.
Okay? All right. Guys, turn to page 11. Okay. What I want you to do right now, instead of me just going over all of my answers, I want you to work on 2, 3, 4, and 5 with your partner. Check your answers. If you got different answers, figure out who did it wrong, who did it right, fix your work.
Page 11. Let's just check. Yeah, 3, 2, 66.
Okay. So for number 2, I say find the percent composition of chlorine in ammonium chloride. What is the first thing for this problem that you gotta do? Before you find molar mass, I gotta write the formula for this compound or else you won't know how many of each element there are, okay? So I have ammonium chloride. Ammonium, remember, has a chart, is NH4 plus. Chlorine is minus, so what would the formula for this be? NH4Cl. Now I'm asking for the percent composition that is chlorine. So I want the mass of chlorine on top, so it's going to be 35.45. And I'm going to divide that by the total molar mass here. And what do you guys get for the total molar mass?
53.49.
Okay, 53.49 or 5, whatever, times 100%. Okay? So what I got for my final answer was 64.39%.
Yeah, I got 66.28. I think a lot of us, when we did it, we used the entire 3.
It would not cause that big of a difference. Who has my calculator? Nope. Someone took my calculator for this class, yes?
This is my calculator.
No?
It's 66.
Am I losing my mind? Give me 1 sec.
There are 2 calculators.
Oh, nope, I'm losing my mind. It's all good. Okay, so give me a sec. 35, give me a sec. 35.45 divided by 53.49. You're right, I'm wrong. 66.
66.28.
I got 66.27.
That's what we got.
If you got 26, that's fine. It's okay. That's definitely 100% wrong. Okay. So number 3, what is the mass percent of chlorine? What is the mass percent of chlorine and potassium chlorate? Again, you gotta write out your formula. Potassium. Chlorate. I think this is where most people made their mistakes. ClO3. So it's KClO3 is potassium chlorate. Again, mass of chlorine is 35.45. Divided by the total molar mass, in this case, 122.55. Multiply by 100. 28.93%. Okay, did you get the 35.45 for chlorine? Did you get 122.55?
Oh,
That's probably what you did wrong.
wait, but I got this. Wait.
Hold on, Miss May. What?
And if you got both of these but got the wrong answer, you probably plugged it in wrong.
That's why oxygen by 3.
Probably your problem. Okay. Now, we've gone over 1, 2, and 3. Are there any questions for 1, 2, or 3? Okay, let's go over 4. I give you lithium carbonate. Remember, lithium has a +1 charge. Carbonate has a 2- charge. So this would be Li2CO3. Okay, and it wants the percent composition of lithium. Now, I've got 2 lithiums, so I've got to take the molar mass of lithium, multiply that by 2, and I got 13.882.
Yes.
I'm going to divide that by the total mass, which was 73.892, and multiply by 100%. So I got 18.79%.
Hey,
Is it over 6?
I just thought it was funny.
Over 73.892.
I think I rounded it. Maybe you just
Sorry, guys, I can't hear Patrick. What did you say?
I think I rounded it wrong.
Okay,
So I got 18.78.
that's fine. Okay, 5. What is the mass percent of oxygen in aluminum hydroxide? Again, write out your formula. What's the charge of aluminum?
26.98.
What is the molar? Sorry, what is the charge of aluminum?
It can't be negative. It's positive.
Positive 3. Are you?
Why can it not be negative, and why did I make that face? It's a metal. It's not going to gain electrons.
Silly, Billy.
Watch it gain electrons. Just spike it.
Okay. Hydroxide is -1. So here, guys, this is somewhere where a lot of people make mistakes. Remember when you're writing this formula, you've got 3 oxygens and 3 hydrogens. Okay, so just be careful. So I'm going to take the molar mass of oxygen. I've got 3 oxygens, so it's 16 times 3, or 15.99, whatever. I got 48. And I'm going to divide by the total molar mass, which is 78.012. And so what I end up getting is 61.53%.
Yeah. We popping up.
Okay? Are there any questions for number 1 through 5?
Now that is spot on. Spot on.
Yes. Shh. Guys, I need it quiet so I can hear her. Yeah, go for it.
Got a completely different answer than before.
Okay, so what part did you look at the work that I did? Did you get Li2CO3? Okay. Did you get 13 for the top? So go back in. How many how many lithiums do you have?
2.
How many carbons?
1.
How many oxygens?
3.
Go back, double check yourself. All right. Now, what we're going to be doing today, what you guys are going to be doing, last class you took your pennies, you filed them down, you created little notches in them, you found their mass. I'm on page 12. Now, one thing that I had said, or one thing you should have noted, for all of the pennies that I gave you, they were all created after what year? 1982. Before 1982, all pennies were made out of copper, pure copper. Now, here's the problem. If you have something that is made out of something that is so expensive that it's more expensive to make a penny than a penny is worth, you've got 2 problems. Number 1, the government loses money every time they make a penny. And number 2, if the amount of copper that's in your penny is worth more than a penny, people started melting down the pennies and selling the copper, which is an issue because that can cause inflation. That can cause you're losing pennies, right? They're being taken out of circulation, just like we did. So instead, in 1982, what they started doing was instead of making the penny out of copper, it is made out of
Zinc.
zinc. Zinc is cheaper than copper. Now, you might say, well, Miss Polliner, you're completely wrong because the penny that I see is made out of copper. It's copper, right? It's not actually. Why does it look like it's made out of copper? Just a very, very slightest small amount of film around it. The rest of the penny itself is pure zinc. Okay?
Nice.
So, if you look,
Why can't they just change the code to what zinc was?
because
So
I
pennies are
freak people
iconically-
out. I don't know which AJ this is.
Oh.
That's my only problem. So let me find a different one. Michael and Arno's. Here's the cool thing. So I took your pennies out of the acid solution.
Currently not here.
Okay. So what you guys will be doing, you gotta get it out so it's not acidic anymore, right? I took the acid out. This is your penny,
Whoa.
okay? Which looks like a perfectly normal penny until you drop it,
Yeah.
and it doesn't go bouncing around. It is just the outside of the penny,
Oh.
Wait, so
right? The
Wait,
inside
what?
is the inside is totally gone.
No way.
That's pretty cool.
Okay, so you guys will be able to get your pennies and you'll keep them, but it's literally just, and this one didn't do a great job. There's a tiny bit of zinc still left, so that'll be a great source of error. But for other ones, they're like pretty much totally, it's just the outside, the coating of it.
So that's what
Yes,
you're
sir.
saying.
Can we
Okay.
use that to
Keep prank cashiers.
So it's officially no longer viable cash, number one. Number two, most places don't take pennies anymore. Number three, you did break the law because you guys did it. You guys, so I'm just letting you know. It is because you destroyed currency.
No, but you put it in the
You guys are the ones who liked it. Because if you were just to take a penny and add it to the acid, nothing would have happened. But by doing by doing the filing, which you guys did, that's why that happened.
Okay, wait.
So you're at fault.
No, I'm curious. Is the actual filing against the law, or is taking out the zinc?
Taking out the zinc is against the law.
I
think so, too.
It's not against the law.
We'll all go to jail.
You did the other
Ladies,
one.
is there a question?
party.
Okay. So last class, what you guys did was you found the mass of your penny all by itself. What you will do now is you're going to find the mass of just the casing of your penny. Okay? Then there are a number of problems here, starting on page 13, including a dinosaur drawing, apparently.
Do you like it?
Your task is to determine the percent of your penny that is zinc, determine the percent that is copper, okay? And then if you flip to page 14, you're actually going to calculate how much the government saves by using a new penny with a zinc versus a penny that was pure copper. Right?
Yeah, it's economics.
If you notice on page 13, it has sections for pre-1982 and post-1982 pennies. You guys are going to grab your pennies, you're going to go and measure in the back. Those are your post-1982 pennies. The pre-1982 pennies, I obviously didn't have you guys all do it because I didn't want us destroying pre-1982 pennies because I don't have that many of them. I'm going to put my data for that up on the board in a second. Okay? So all of those questions are actually on Schoology. It has a list of everything you need to answer. It's going to be 2 paragraphs that you guys write out. But during class right now, you guys actually need to do all the calculations. Okay? Marion and Patrick. It'll just be a source of error, and you're fine. There's nothing we can do about it. The percentages will be a tiny bit off, but it's okay. Some of them, there's like almost nothing left. Yeah, Patrick.
I know it's a small object, but is there like a noticeably different weight?
Mass? Yes. Because you got rid of for most of you guys, you got rid of all the zinc, which is most of the mass of the penny.
The zinc penny and then the copper.
Oh, the difference between them? Not that big of a. You mean when they're whole? No. Yeah. Are there any other questions?
Oh, yeah.
Yes.
How does the casing just stay in the circle?
Some of it does. Sometimes it falls apart. So.
How did it not fall?
I have no idea about this entire concept. So is it essentially just remain inside?
Do you see how the casing is like dead? So that's AJ's, but I'm not sure if it's this AJ or the other AJ.
It's probably the other.
Did you put it in a flask?
I think.
We'll see. We'll see which ones are left over. Okay. So guys, your task right now is to grab your pennies. Okay. You need to draw.
Is this one mine?
It is.